Hi, today we're looking at Functional Skills Maths Level 2. We've got the Pearson Edexcel exam board. This is set 9 and we're starting off with the non-calculator section. Question 1. Shannon has a new car. The petrol tank has a maximum capacity of 48 litres. The cost of petrol is 126.7p per litre. Shannon thinks it will cost less than £70 to completely fill an empty tank with petrol. Use estimation to check if Shannon is correct. You must show your working. Right, so they want us to use estimation, okay? So even if you can work this out accurately, it's not what they want, so you won't get full marks for that, okay? So let's think about what we'd need to do. She wants to know if it will cost less than £70 to completely fill a tank. Well, let's work out how much we think it will cost to fill a tank. But remember, we're using estimation. So what that means is, well, instead of 48 litres, we're going to say, well, that's approximately equal to, well, it's close-ish to 50. So we're looking to round it, really. So either to the nearest 10, or the nearest 5, or the nearest 100, whatever seems most sensible. In this, it's close to 50, so we're going to do that. And the reason we're doing this rounding or this estimating is to make our calculations more simple, easier for us to get a sort of an approximate answer. Now the cost of petrol is 126.7p per litre. So again, I'm going to go for the nearest 10 again. So 126.7, well, it's going to be between 120 and 130, and 125 would be in the middle. So 126.7, we're going to say that's approximately equal to 130p. Okay, so if we want to work out what the cost is, well then what we want is 130 times 50. Now, we can do that using the column method, but in fact what I'm going to do is I'm going to ignore the zeros for now. Just going to do 13 times 5. So 5 times 3, we've got 3, 6, 9, 12, 15. 5 carry the 1. And 1 times 5 is 5, add the 1 is 6. So we've got 65. Now, we had 2 zeros here. So if we put the zeros back on, we need to put the zeros back in the answer. Now at the moment, that's 6,500. That's p. So if we want to turn that into pounds, we need to take the 2 zeros off and say, well, that's £65. Shannon thinks it will cost less than £70. Well, £65 is less than £70. So, yes, she is correct. Question 2. Henry is designing the car park for a new shopping centre. The total number of parking spaces at the shopping centre will be 900. 150 of the parking spaces will be for staff. The rest of the parking spaces will be for visitors. Henry wants 6% of the visitor parking spaces to be parking spaces for disabled visitors. Work out the number of parking spaces for disabled visitors in this car park. So there's a couple of steps we need to do with this one. First, we want to think about, well, how many of these spaces are for visitors? And then when we know that answer, we want 6% of that answer. Okay. Well, if 150 are for staff and the rest are for visitors, we need to start with the original 900 and subtract the 150 for staff. This is going to tell us how many spaces we've got for visitors. So 0 minus 0, 0. 0 minus 5, well, we can't take 5 away from nothing. So we're going to reduce our 9 to an 8 and pass 1 over to make this 10. So 10 minus 5 is 5. 8 minus 1 is 7. So we've got 750 spaces for visitors. Okay, well, we wanted to work out what 6% of the visitor spaces are. So 6%, so we can do it in a couple of different ways. Well, if we want 6%, what we're saying is we want 6 out of 100 times the original 750 spaces. Okay. This isn't the only way to work this out, but I'm going to do it this way because I think with these numbers this might be a nicer way to do it. So what we can say is, well, we've got 6 divided by 100 times 750. Well, we can cancel a 0 with a 0 there. And really, although we've got 6 divided by 10 times 75 now, we can do the top first. So we can say this is the same as 6 times 75, and then divide it by the 10. So if we work out this bit first, so saying what's 5 times 6? Well, we've got 6, 12, 18, 24, 30. And 7 times 6, or 6 sevens. So we've got 7, 14, 21, 28, 35, 42, plus a 3, 43, 44, 45. So we've got 450. Now, we also had to divide by 10. So if we're dividing this by 10, we can just take this 0 off the end. So we're going to get an answer of 45 disabled spaces. Question 3. Here is a list of numbers. Find the median. Okay, so the median is the middle number. Well, the first thing we're going to want to do is we're going to want to sort these or put these in order of increasing to decreasing. So it looks a bit messy up here because we've got a different number of decimal places. So I'm going to write them all out, but one above the other. So 12.96, 12.096, 12.9, 12.45, 12.1, 12.738, and 12.62. Now, because I want to compare these numbers, I'm going to fill in any gaps at the end with zeros. So I'm not changing the values, but what it means, especially as these numbers are all 12s here, I can ignore these because they're all the same. And I just compare these. So we've got 960, 96, 900, 450, 100, 738, and 620. So I want to put them from smallest to largest. Well, the smallest is this 96. Next smallest is 100. And what have we got? We know these are the 900s. 400's going to be next. Then the 600 one. Then the 700. Then we've got 900 and finally 960. Okay, so now we can write them out again. Now, we don't have to do this. We could sort of say, I could write them out in order, but I could say we've got 7 numbers. So 1, 2, 3, 4, 5, 6, 7. Now, if we were trying to find the median, we would cross off the 2 at the ends, and we'd keep doing that until we've got 1 left in the middle. And you see the one we left in the middle is the 4th number. And the 4th number is this one down here, which, although we've got it as 12.620, in fact, it was given to us just as 12.62. So you could write all of these out again, but as I say, it might just be easy to think of, well, which position is it I want, and then pick that number from there. Okay, so we've got part B here now. Work out 7/8 minus 3/5. So I'm going to write it out down here. Well, if we're doing addition or subtraction of fractions, first thing we look at are the denominators, the numbers at the bottom, the 8 and the 5. If they're different, well then we need to make them the same. And the first thing we look at is whether one of the denominators goes into the other. So 5 goes into 8, but not without a remainder. Okay, so that means that we're going to have to change both of the denominators. And we want to think, well, what numbers would 5 and 8 go into? So I'll start with the bigger number, and I think, well, what's the 8 times table? Well, we've got 8. 5 doesn't go into it evenly. Then we've got 16. 5 doesn't go into 16, because for 5 to go into the number, it's got to end in a 5 or a 0. Another 8, we've got 24. No, it doesn't work. 32. 5 still doesn't go into. Then we've got 5 8s are 40. Well, 5 goes into, well, if we know 5 8s are 40, well then 5 and 8 must go into it. So that means that we can rewrite both of these fractions as being out of 40. Okay. And we said 5 8s are 40. So what we're doing is we're multiplying the top and the bottom by 5. Because 5 times 8 we said is 40. So if we want to keep the value of the fraction the same, we need to do 5 times 7 as well. So we've got 7, 14, 21, 28, 35. So we're saying 7 eighths and 35 40ths are equivalent fractions. And if we do the same over here, well, it's not going to be 5 anymore, because we're saying, well, from 5 up to 40, well, actually, if it was 8 times 5 is 40, we're saying we're going to multiply that by 8. Because if we do 5, 10, 15, 20, 25, 30, 35, 40, we need 8 5s to get to 40. So again, to keep the value the same, we need to multiply the top by 8 as well. So 3 lots of 8, we've got 8, 16, 24. So these are equivalent fractions as well. 3/5 is the same or equivalent to 24 over 40. The reason for doing all of that is because the denominators are the same, we can say, right, well, the answer is still going to have that same denominator. And all we need to do is 35 minus 24, which we can write down up here. So 5 minus 4 leaves 1, 3 minus 2 leaves 1. So we've got 11 over 40. We can put that down here. Okay, question 4. Rafi wants a 2-story extension built on the side of his house. This scale diagram shows the plan view of the floor for each story. Okay, and we've got the scale is 1 to 50. Okay, so we're just looking straight down on top of it. Rafi looks at the websites for different builders. This table shows the cost per metre squared to build a 1-story extension, so just 1 floor. For builder A, the cost per metre squared is £1,300. For builder B, it's £1,350, and so on for the different. We've got 8 builders here. Rafi will use the mode of these costs to help work out the expected cost to build this 2-story extension. He also knows that the cost per metre squared to build a 2-story extension is 1.5 times the cost per metre squared to build a 1-story extension. Right, so these costs are if they just want to build 1 floor. If we want 2 floors, then we use the same costs per metre squared, but we need 1.5 times. Okay. So let's get to the actual question. Work out the expected cost to build the 2-story extension for Rafi. You must show your working. Right. Now, the expected cost, what that's telling us, often expected would mean rounding, but if you see, they tell us that Rafi will use the mode of these costs to help work out the expected costs. So we're not rounding, the expected bit we're talking about is the fact that we're using the mode. And the mode is the value that occurs the most. Okay, so the way we're going to find out which of these numbers occurs the most is, as I come across one, so 1,300, I'm going to see how many of those have we got. We've got 1 here, 2, so let's cross off 1, 2, 3. Okay, so that occurs 3 times. Then 1,350. We've got 1, 2, so we've got that twice. The next value, 1,325. So we've got that once, and that's it. What's the next value? 1,340. We've got that once, that's it. And finally, we've got 1,290, and we've got that once. So we want the value that occurs the most. Well, this occurs 3 times, and that's the most. So the value that occurs the most is £1,300. Okay, so what we've got is we've got our £1,300, and that is per metre squared. Okay, so what we need to do is we need to work out how many metres squared we need. Okay, so the way we can do this is we're told we've got a scale here, and the scale is 1 to 50. So what we'd need to do is actually measure the size of this. Okay, now this can always be a bit tricky with scale questions if you're using papers that you're printing off from the internet, because what you'll notice when you print these off, it's got this bit that says do not write in the margin, or do not write in this area, and that means that actually in real life this page would be bigger. So, and there's not really a great way around this. So if I measure this, you can see it's about 9 centimetres. But if you're comparing this to the mark scheme, or if you had this in the exam, I can tell you that if I measured this on the real full-size paper, it actually comes out at 10 centimetres. Okay, so you sort of have to just sort of trust me on this one almost, because these are the numbers that you'd need to use if you did it in the exam. And the distance going across, although we've got 14 or just over 14 centimetres here, again, if you did it on the real exam paper, you'd get 16 centimetres there. Okay, so what we've got to think about is, if you take that as a given, that in the exam you would have measured 10 centimetres that way and 16 centimetres that way, we've then got to use the scale to work out what are these sizes in real life. Okay, because this is just the measurements on the picture. And if it's 1 to 50, what we're saying is that 1 centimetre on here is 50 in real life. So 10 centimetres on here, well, we'd have to multiply that by 50. And if we do that, well, 1 times 5 is 5, and then just add the 2 zeros. So that would be 500 centimetres. Okay, that's great, but if you remember, we were working in metres squared. So how can we turn this into metres? Well, we know that we've got 100 centimetres in 1 metre. So if we want to turn this into metres, we divide it by 100. So that means we can just cross 2 zeros off. So we've got 5 metres. So we can do something similar with the measurement up at the top. So remember, we want to multiply it by 50. Well, first I'm just going to multiply it by 5. I'm going to ignore the 0. So 5 times 6 is 30. 1 times 5 is 5, plus 3 is 8. Then I want to put the 0 on to make it 50, so I can just put that on there. So that's telling us that 16 centimetres on the picture is 800 centimetres in real life. And again, to turn it into metres, we then need to divide that by 100. So cross off 2 zeros, and that gives us 8 metres in real life. Okay. So the area we've got is going to be 5 times 8. So we've got 8, 16, 24, 32, 40. So the area is 40 metres squared. Okay. And we saw from down below, when we were working out the mode, our mode was £1,300 per metre squared. So all we need to do is multiply those two together. Okay, so we've got, well actually it's not just as simple as that, is it? Because we need the area times the cost per metre squared, but we've also got, this is a 2-storey extension, so we've got to multiply it by 1.5 as well. So I'm just going to write this, I'll write this up here. So what we're trying to do is we need 40 times 1.5, or 1.5, and then also times 1,300, because that's the cost per metre squared. Now we just want to work out, because this is the non-calculator section, what's going to be the easiest way of multiplying these all together. Okay, because they're all multiplied, so you can choose. Now I'm looking at the 40 and thinking, well, I think if I want to do 1.5 times 40, I can work out half of 40 quite easily. So I'm going to go with this bit first. So 1.5 times 40, well, half of 40 is 20. So 1.5 would be 40 plus 20, which if we add the tens, it's going to be 60. Okay. So we want 60 times 1,300. Well, let's ignore the zeros. So we do 6 times 13. 6 times 3, or 3 times 6, we've got 6, 12, 18. 8, carry the 1. And 1 times 6 is 6, plus 1 is 7. So we've got 78. But what we wanted, I'm going to write it up here, we wanted 1,300 times 60. So we've got 2 zeros to add on here. We can add them on the answer. And 1 0 to add here. Add that on the answer. So we've got 78,000. That's going to be pounds. Okay. And that is our cost. And just to show it's complete, that's what we need to write down there. So that's the end of the non-calculator section. And now for the calculator section. Question 1. Thalia owns a chocolate factory. The workers in the factory work 7 hours per day. They produce 65 boxes of chocolate per hour. Thalia gets an order for 9,100 boxes of chocolates. Work out the number of days needed to produce 9,100 boxes of chocolates. Okay, well, if we start off with the 9,100, that's how many boxes they need to produce. If we know they can do 65 in an hour, if we do 9,100 divided by 65, this is going to tell us how many hours they need to work for. And it's the calculator section, so 9,100 divided by 65, so that's 140 hours. Okay, now we want to go from hours into days. Well, the workers work 7 hours a day, so we want 140 divided by 7, which gives us 20 days. And remember to put your answer in the box at the bottom as well. Question 2. Thalia has 6 machines to produce chocolate in her factory. Each machine produces the same amount of chocolate. It takes 3.5 hours for these 6 machines to produce enough chocolate to fill a crate with chocolate bars. On Tuesday, only 4 of the machines are working. Work out the number of hours the 4 machines will take to produce the chocolate needed to fill a crate with chocolate bars. Right, so at the moment, we've got 6 machines, and each of them is working for 3.5 hours. So 3.5, we can put that as 3.5. So if we multiply 6 by 3.5, this is going to tell us the total amount of work needed. So 6 times 3.5. So there's 21 hours of work needed in total. We've only got 4 machines working now. So that 21 hours has got to be shared by the 4 machines. Which gives us 5.25 hours. And we can put that in our answer box. Okay. Now remember, it's 5.25 hours. It's not 5 hours and 25 minutes. If you wanted to convert the 0.25 into minutes, so you could say 5 hours and 15 minutes, that's fine. But they haven't said in hours and minutes, they've just said hours. So 5.25, that's the quickest, easiest way to do it. Okay, leaving it as a decimal. Question 3. The scatter diagram shows information about the outside temperature and the number of gas units used to heat a house on each of 10 days during January. So we've got the temperature along the bottom, and going up here, this is the number of gas units. Okay, and we're told the range of the number of gas units used to heat this house each day during October was 11 gas units per day. Jensen thinks the number of gas units used to heat this house each day is more consistent in October than in the 10 days in January. Is Jensen correct? Show why you think this. So we know the range for October. We need to work out the range for January. And the range is the biggest value, or well, it's the difference between the biggest value and the smallest value. So the biggest value here is this one. So let's see what this is. So if we read it across to here, we've got 20 here and 30 here. So we've got to work out what each of these boxes is worth. We've got 1, 2, 3, 4, 5 boxes, and it's going from 20 to 30. So we've got a difference of 10. So it must be going up by 2 each time. So that would be 22, 24, 26, 28, 30. So this one here must be 24 gas units. And we also want the smallest value. So the smallest value is this one over here. And let's read it across. So if we work out what this is, well, it's 2, 4, 6, 8 gas units. So our range is going to be the 24 minus 8. And you can use your calculator if you want. We've got 16 gas units per day. Okay. Right, now we need to compare that to October. Well, 16, where should I put this, is greater than 11. So it means that it was more consistent in October. Because the more consistent one is going to be the one with the smaller value. More consistent in October. So the actual question, is Jensen correct? And Jensen thinks the number of gas units used to heat this house each day is more consistent in October. Well, we're agreeing with that. So, yes. In fact, we can put that down here. We can say yes. And our reason is because 16 is greater than 11. And then part B. Jensen also thinks there's no relationship between the outside temperature and the number of gas units used to heat this house in these 10 days in January. Is Jensen correct? Give a reason for your answer. So he thinks there's no relationship. Well, actually, if I look at this, and a good way to do it with a scatter diagram is to see, is there a way we can draw a line of best fit? So we want a straight line going through the data, which follows the overall shape, so it's going to be sloping down. And we want roughly the same number of points above the line as below the line. Now, it doesn't matter if the line goes through any of the points. It certainly doesn't have to. So that's going to be my line of best fit. Yeah, and it's broadly following the pattern. And it appears that as the outside temperature gets higher, the number of gas units gets lower. Yeah, so when it's -3, there's 24 gas units used. When it gets up to 5 degrees, a +5, only 8 gas units are used. So for me, that's looking like a negative correlation. Okay, as one thing gets bigger, the other thing gets smaller. So Jensen thinks there's no relationship. Is Jensen correct? I say no. Because there is a negative correlation. Okay. In fact, if we want to put that in words as well, we can say as the temperature increases, move this up, the number of gas units reduces. Question 4. Caddy runs a household waste centre. Rubbish collected at the centre is either sent for recycling or sent to landfill. The table shows information about the weight of each type of rubbish sent for recycling last month. So we have the rubbish type and the weight in tonnes. So garden waste, we had 224.56 tonnes, wood and cardboard, 101.81 tonnes, and so on. The total weight of rubbish collected at the centre last month was 653.64 tonnes. So that's the total of all rubbish. Remember, this is just for recycling. What percentage of all the rubbish collected last month was sent for recycling? Give your answer correct to the nearest whole number. Well, so we need to know what the total is of all of the recycling, first of all. So we can put these in. 224.56 plus 101.81 plus 37 plus 138.9 plus 16.54 plus 82.45. That gives us a total of 601.26 tonnes. We want the percentage that was recycling, so it's going to be our 601.26 out of the total, which was 653.64. And to make it a percentage, we're going to multiply it by 100. So we've got the 601.26 in there, divide it by the 653.64, multiply it by 100, and we've got, well, what have we got here? Have they said they want the answer to the nearest whole number? It was 91.9. We want just the whole number bit, because it's a 9, we're going to round that up to 92%, which we can then put down here. Question 5. Natalie will plant flower bulbs on a road roundabout. The roundabout is in the shape of a circle with diameter 14 metres. So we've got this here, so all the way through the circle is 14 metres. Natalie will plant the flower bulbs in a circle 75 centimetres from the edge of the roundabout. So this dotted line here. The dashed line in the sketch below shows where the flower bulbs will be planted. Natalie will plant a flower bulb every 25 centimetres starting from point S. Okay, so one here, 25 centimetres long, another one, and another, and another. The flower bulbs are sold in packs. Each pack has 16 flower bulbs. How many packs of flower bulbs will Natalie need? So the first thing we need to work out is how big is this circle? Not the outside circle, but the dotted circle, which is the one that we're planting the flowers on. So we've got to think about, if we want the circumference of a circle, this will tell us what we're going to need. Circumference. Well, the formula for that is, well, you can think of it as 2 pi r, or you can think of it as pi d, where pi is 3.14 and d is the diameter. Okay, because we're working with diameter, we were given the diameter, so we might as well use this version of the formula. Right, but we've got metres and we've got centimetres. So let's convert these so we've got them all in the same units. Well, I know we've got 100 centimetres in 1 metre. So if we multiply this by 100, so 14 times 100. That means we've got 1,400 centimetres. Now that's all the way across. What we want is the diameter of this circle here. So this distance. Well, it's going to be the full distance we had to start with, but we want to take off 75 centimetres this side, so minus 75, but also another 75 centimetres down here, so minus another 75. So if we do that, 1,400 minus 75 and minus another 75, and we get 1,250 centimetres. So that's our diameter of the circle that we're interested in. So our circumference or you could just put C for short, is going to be, well, our formula we said was pi d. So pi is 3.14. And when you've got a formula like this, if you've got two letters together or a number next to a letter, it means you need a multiply sign in between. So 3.14 times 1,250. We've already got that in our calculator, so we can now multiply it by 3.14. And we get 3,925. That's centimetres. That's the distance of this dotted circle all the way around. Okay, now we want to know, well, how many flower bulbs does she need? Right, well, we're going to plant one every 25 centimetres. So we want 3,925 divided by 25. That's going to tell us how many bulbs she needs. And that's 157 bulbs. Bulbs come in packs of 16. So we then need to do 157 divided by 16. And we get 9.8125 packs. But you won't be able to buy 0.8125 of a pack. So we're going to need the number of whole packs, which is going to be 10 packs. Okay, question 6. Andrew is training to run in the New York Marathon. The New York Marathon is 26.2 miles long. The qualifying times to run in the New York Marathon are shown in the table below. So if you're aged between 18 and 34, you need to run a time of 2 hours and 53 minutes. If you're between 35 and 39, it's 2 hours and 55 minutes. And so on. So as you get older, the time you need to qualify gets bigger. Andrew is 51 years old. His current average running speed is 8 miles per hour. Andrew thinks he will need to run at a faster speed to be able to qualify for the New York Marathon. And the actual question down here, is Andrew correct? Right, well, let's have a look. He's 51 years old, so he's going to fall into this category. So he's got a time, or a target time, of 3 hours and 14 minutes. Okay, so we've got to work out whether he can meet that target time if he's running at 8 miles per hour. Well, 8 miles per hour, and he's going to be running for 26.2 miles. That means that it's going to take him a total of 8 times 26.2, 209.6 hours. Okay. Well, what we can do here is say, well, we know that there's different ways you could do this. So you could take 60 minutes off this. Yeah, you could keep taking 60 off of this, and that would be your number of hours, and then see how many minutes are left. What I'm going to do, though, is I'm going to divide it by 60. Okay. And this is going to give me the number of hours but as a decimal. So it's 3.49, we'll do it to 2 decimal places, so 3.49 hours. But we've got to compare this to these times, which are in hours and minutes. Well, we know we've got the 3 hours. We want to know what's this equivalent to in minutes. So if we take off the 3, just to get the 0.493 bit, multiply that by 60, because there's 60 minutes in an hour, and we're getting 29.59. So if we round up, so that's going to round up to 30 minutes. So this is 3 hours, 30 minutes. Well, that's clearly longer than 3 hours and 14 minutes. So, yes, he is correct. He will need to run faster. And show why you think this. Well, that's what we've just done there. Question 7. Here is a sketch of a square-based pyramid and one of the triangular faces. So what they mean is like one of these sloping sides. Okay. So we've got a base of 4 centimetres. The slope length is 3.2 centimetres and the vertical height straight up is 2.5 centimetres. Draw an accurate net of this pyramid on the centimetre grid below. Okay, now before I do an accurate drawing, I'm just going to think, well, what's the net going to look like? Well, we've got our base, which is 4 by 4, and then we're going to have these triangles coming off it. Okay, and we know that this distance is going to be 2.5 centimetres, and we want the point to be halfway along here. So that would be about 2 centimetres. Okay, so I'm just planning it out. So in that case, let's start off with our middle square, which we know is 4 by 4 centimetres. So let's pick where's roughly in the middle. You could work it out accurately, but I'm sort of doing it by eye. If that's a corner, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that looks about right. Now, I'd do this, either measure it accurately first, or do it with a pencil in the exam, so you can rub it out if you need to. So this is going to be my base. I'm trying to write a bit thicker lines so you can see exactly where I've drawn it. Okay, so that's my base. Now we've got to worry about these. There it is. These triangle bits. Actually, let me do this side a bit darker as well. Right, so we know that halfway along would be here, and we want the point of each of the triangles to be 2.5 centimetres up. So I can mark that there. Then I just need to join that to the corners of the base. Oh, that one's a little bit off, that's all right. So again, do the same over here. We want 1, 2.5, and then connect these. And on this side, halfway is here, so 1, 2.5. Up at the top, halfway is here, so 1, 2.5. And there's our net. Okay, part B. The base of a tin of paint is placed on the floor. The tin of paint is in the shape of a cylinder. Draw a sketch of the plan view of the tin of paint. Right, well, a cylinder is going to be something like that. If we want the plan view, that's just looking at it directly from on top. Well, that's just going to be a circle. If you've got a compass, you can use that, but it does say a sketch, so it doesn't have to be super accurate. That's going to be good enough for our sketch. Question 8. Dave needs to make 3,500 pounds of concrete mix using cement. If you don't know the fact that this is pounds, again, it doesn't matter. It's just 3,500 somethings of concrete mix using cement, sand and gravel. He will mix cement, sand and gravel in the ratio 1 to 2 to 5 by weight. Cement, sand and gravel are sold in kilograms. Dave uses this graph to convert between pounds and kilograms. Work out the weight in kilograms of cement, of sand and of gravel that Dave needs to buy. You must show your working. Okay, right, so let's start off by getting rid of our weight in pounds and turning everything into kilograms, because that's what we're interested in. That's what they're sold in. So we want 3,500 pounds. Well, our graph here only goes up to 40 pounds. Okay, so initially it looks like that's not going to help us. But actually, if you think, well, 3,500, if we take the zeros off, well, then we've got 35, which fits on the graph. So if we just think of this as, well, it's 35 to get the two zeros times 100. So what we can do is we can find out the weight in kilograms for 35 pounds and then just multiply that by 100. So reading off over here, so this is 16 kilograms. Okay, so we can say that 35 pounds LBS is equal to 16 kilograms. So 3,500 LBS, that is a B, a funny B, is going to be, if we put two zeros on the end, it's going to be 1,600 kilograms. Okay. Right, that's what we need to get. So in fact, I'm going to write that down here. 1,600 kilogram needed. Okay, and that's of concrete. So that's the total mix. Right, so let's start to work with our ratios. So I'm going to draw a table. And in our table, we're going to need cement, sand, and gravel. And then we're going to have a total column. But actually the total is what they're calling concrete. Because you mix these things together, you get concrete. But I think it's clearer because we're used to having a total column. So we're going to have that in there too. And the ratio that they gave us, if we just look here, cement to sand to gravel is 1 to 2 to 5. Make sure we're keeping them in the same order. So 1, 2, 5. Now, if that's all we had, 1 plus 2 is 3, plus 5 is 8. But what we're actually saying is, well, we haven't got 8. We've got 1,600 kilograms. So we want to think, well, how are we getting from the 8 to 1,600? So we do it in reverse. We say, well, 1,600 divided by 8. Now, you might be able to do this without a calculator, because you might say, well, 16 divided by 8 is going to give me 2. And then you put the zeros on to get 200. So what we're saying, to get from the ratio line to the next line, we're multiplying by 200. So the cement, 1 times 200 is just 200. The sand, well, 2 times 200, 2 times 2 is 4, so 400. Again, you can use your calculator, which is fine. And 5 times 200, or 5 times 2 is 10, and then put the zeros on. And we can check, because 200, in fact, let's do it, 200 plus 400 plus 1,000 gets us back to 1,600 kilograms. Okay, so now all we need to do with that is to put it in our answer sheet. Okay, so if we look over here, this is where we need to put our answers. So how much cement have we got? Well, we had 200 grams of cement. Sand, we had 400 grams of sand. And gravel, we had 1,000, sorry, not grams, kilograms. And gravel, we got 1,000 kilograms. Okay, now for part B, show a check of your ratio calculation. Well, that's what we did already, really. We said that 200 plus a 400 plus a 1,000 equals 1,600, which is what we want. So that's the benefit of doing a nice ratio table like this. Not only does it get you your answer, but it does a check for you as well. Okay. Question 9. Here is a centimetre grid. And we've got this marked out. We've got our x-axis, we've got our y-axis, and we've got points A, B and C on there. And the first question, write down the coordinates of point B. So this is B, so we want the x coordinate first. So we're looking up here. So we've got -5. And then we want the y coordinate, so this one, which is going to be -4. Now it tells us that D is a point on the grid. The trapezium ABCD, so what they're saying is if you connect all those points together, it will make a trapezium. And it has exactly 2 right angles and one side of length 9 centimetres. Plot a possible position for point D on the grid. Right, so we've got to make a trapezium using these points and an extra point that we're going to put on, which is going to be point D. Well, what I'm going to do is I'm going to join these together, so I've got 3 sides. Well, 3 points to connect it, so we've got 2 sides. So I'm guessing D is going to be over here somewhere. Okay. Now we need exactly 2 right angles. Well, we've got 1 right angle here already, so we need 1 more. And we need a side of length 9 centimetres. Well, let's see, what have we got? We've got 1, 2, 3, 4, 5, 6, 7. So that's 7 centimetres, so it can't be that side. And this one, 1, 2, 3, 4, 5, that's 5. So it can't be that side. Now let's think about what a trapezium is. Well, I know a trapezium has got 4 sides, and I know it has 1 pair of parallel sides. So I need a line that's going to be either parallel to this line or parallel to this line. And it doesn't really matter which way you do it. I'm going to do it parallel to this line, so I'm going to have my line going up. And we need it to be 9 centimetres long. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means that we connect that there. And by doing that, we get another right angle. So we need a trapezium, which we've got, 1 pair of parallel sides. It's got to have exactly 2 right angles, 1 and 2, and 1 side of length 9 centimetres, which is this one. Done it. And they just asked us to plot a possible position for point D. So they haven't asked for the coordinates, they just want us to plot it on there. Question 10. Here is a cone. Here's our lovely cone. We've got 8 centimetres across, so that's the diameter, and 12.8 centimetres up. And we're told that V equals 1/3 of pi r squared h. So 1/3 times pi times the radius squared times h. And V is the volume, r is the radius of the base of the cone. So down here, so r would be that distance. And h is the vertical height. So that's h. Work out the volume of this cone. Remember to state the units. Okay, well, we can put the values in. So the volume is 1/3 times pi, which is 3.14, times r squared. Well, we haven't got r yet, but we know that the radius is half of the diameter. So let's say that r is going to be 8 divided by 2, which is going to be 4 centimetres. So for r, it's 4, and it's r squared, so it's going to be 4 times 4, and then times h, which is the height, which is 12.8. So we can put this all in the calculator. Now you might remember from some of my other videos that when we're doing a third, we're going to get, oh, that's not a third, that's a half. A third, we're going to get lots of decimal places. So we could multiply by the whole numbers first, but I'm going to do it in this order because this is how it's written. So we've got 1/3 times 3.14 times 4 times 4 times 12.8. And we get an answer of 214.35729. They haven't said what to round it to. I'm going to round it to 1 decimal place, I think. So that would be the 3. But if this is 5 or more, we need to round that up. So it's going to be 214.4. And the units, which they've told us to be careful about, are going to be in centimetres cubed. And we can write that in here. Question 11. Darius restores old furniture. He has 12 chairs and 3 tables to restore. Darius writes a list of the costs to restore all of the chairs and all the tables. So the tables and chairs are free because he's already got them. He needs 7 tins of wood oil, £12.50 each, so that's for each tin. 10.5 or 10.5 metres of fabric, at £6.90 per metre. And foam cushions, which are £82.50. Now it's saying cushions, so I'm assuming that's for all of the cushions that he needs. Darius sells each table for £127 and each chair for £32. Work out the percentage profit Darius makes after selling all the chairs and all the tables. Give your answer correct to 1 decimal place. So we want to know how much he's going to make, or so how much money he's going to get from selling these, but also how much it's going to cost him. So we've got the costs up here. So let's do the costs first of all. So it's 7 tins at £12.50 each. So 7 times £12.50 is going to be £87.50. 10.5 metres of fabric. That's 6. So 10.5. £6.90 each. So 10.5 times 6.9. That's going to cost us £72.45. And the foam cushions, well, that's just a cost of £82.50. So let's work out the total of all of that. So we've got the £72.45, add on the £87.50, and then add on the £82.50 for the foam cushions to give a total cost of £242.45. Now, how much is he getting for the tables? Well, he's got 3 tables. So 3 times 127, put that in brackets, and 12 chairs. So 12 lots of 32. We'll do this in 2 parts. So 3 times 127. 3 times 127. I'm going to make sure I don't rush. You need to do the same. But it's also good if you do make a mistake. For example, I think I did 2 times 127 or something. I could straight away see my answer was wrong. Because I know if I'm doing 3 times 100 and something, well, my answer's got to be at least 300. Okay, so do that as you're working. Don't completely trust your calculator because you might type something wrong. So just look at it and think, does my answer look sensible? which it does. So for example, 12 times 32, well, I know 10 times 32 would be 320, so I want something more than that. 384, which looks sensible. So add those two together, 765. So we're interested in the percentage profit. Well, let's work out the actual profit first of all, before we turn it into a percentage. So it's going to be the amount of money he gets minus all the costs. So 765 minus 242.45 gives us £522.55. So to work out the percentage profit, we take the actual profit and divide it by the costs, which are £242.45. Turn it into a percentage, we multiply it by 100. Right, now this might look a bit odd because we're going to get something which is quite large. So we've got a 206.99. Okay, in fact, let's just check. Did we type that in? 522.55 divided by 242.45. Yeah, no, I think I typed something wrong as I was going there. Always good to check these, double check them. So 522.55 divided by 242.45 multiplied by 100. That's better. So 215 point. We'll do it to two. They've said to one decimal place. So the 5 would be the first decimal place. 2 is less than 5, so we can just leave it as 5, and that's a percentage. So saying that the number might look a bit odd because it's so big, but it's just saying you're making a lot of profit. So 200%, so more than double what it cost. That's how much money you're making on it. Yeah, so that's good business. Question 12. Jasmine is doing a survey about learning to drive. The table shows information about the number of driving lessons 60 people had before passing their driving test. So 6 people had only 1 to 15 driving lessons, 18 people had between 16 and 30, 25 people had between 31 and 45 lessons, and 11 people had between 45 and 60 lessons. Jasmine estimates that the mean number of driving lessons these people had before passing their driving test is more than 35 lessons. Is this estimate of the mean correct? Show why you think this. Right. Well, the reason it's an estimate is that we don't know exactly how many lessons everyone had. We've just got these ranges. So what we're going to do is we're going to have a midpoint because we can't work with a range. So we've got to say, well, let's assume, well, they didn't all have 1 lesson. They didn't all have 15. So they all had somewhere in the middle, the midpoint. And the way we work out the midpoint is we add the 2 extreme values together, so 1 and a 15, and then divide it by 2. So 8 is right in the middle. Okay, let's do that for all of them. So for 16 to 30, make sure you press equals before you do the divide. We've got a midpoint of 23. 31 to 45, the midpoint's 38. And 46 to 60, the midpoint is 53. Okay, so that's the midpoint. We want to know, if you think about mean, when you're working out the mean, you want the total divided by the frequency. Well, the total is going to be the total number of lessons. 8's the midpoint, but that's just for one person. If we've got 6 people, we're going to need to multiply those together. So that means for this range, there were a total of 48 lessons. So this is the frequency times the midpoint. So we're going to do this for all of these ranges. Okay, so 18 times 23, 414, 25 times 38, 950, and 11 times 53, 583. Now, if we add these together, this is going to tell me the total number of driving lessons for all of the people. So 48 plus 414 plus 950 plus 583. And we get a total of 1,995. So that's the total that we're referring to up there. So there are a total of 1,995 lessons. The frequency, well, that's going to be this total frequency here. So we can add these together, but in fact we were told there were 60, so we should get 60, which is good. So that's the total number of people. If we divide 1,995 by the 60, this should tell us the average number of lessons per person. So it should be somewhere between 1 and 60. We're expecting it to be somewhere in the middle, maybe in the 30s. And we get 33.25. Jasmine estimates the mean is more than 35 lessons. Well, 33.25 is less than 35. So is the estimate of the mean correct? No. It's incorrect. Part B. Use a reverse calculation to show a check of your answer. Well, reverse calculation means doing it backwards. So we start with the answer, which was our 33.25. We divided by 60 to get this answer, so we'll do the opposite of that, which is multiply by 60. So still in our calculator, multiply by 60 takes us back to 1,995. There's our check. One of these 60 people is chosen at random. What is the probability that this person had more than 30 lessons before passing their driving test? Give your answer as a decimal. Okay, so we want probability that this person had more than 30 lessons. Well, we know that there were 60 people in total, so that's our denominator. We're interested in the number that had more than 30. So let's go back and look at the original data. Well, more than 30 is going to be these ones. 31 to 45 and 46 to 60. So we want the 25 and the 11. Well, 25 plus 11 is going to give us 36. So 36 out of 60 people is our probability. They've asked us to give your answer as a decimal, so we just do 36 divided by 60 to give us 0.6. And write that in at the bottom. And you can see that's now the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on. Good luck with your exams if they're coming up soon, or if you're targeting May or July, and look forward to seeing you again soon. Thank you.